So, David, I've seen your many posts, I've seen your many comments about so much activity and innovation and evolution that's happening in the cloud AI space. Before we get into architecture itself, the current state of AI, Gen AI in the cloud, how would you summarize it in terms of how it is now, in terms of where it's going in the immediate future?
I think you still consider, even though the capabilities are amazing, that it's still early days. So in other words, we've had machine learning capabilities for a long time. If you look at generative AI, it's basically a version of machine learning. We're able to, generate outputs in any number of ways of doing it using the LLMs. Any number of ways of audio, data, things like that. To the flexibility and our ability to use the knowledge model is really what's kind of net new here. So they have the open source tools and they have their own tools in the systems. And those have been around for a long period of time. They're just adding the additional generative AI tooling to kind of take everything to the next level. And everybody has a pretty good solution now. Obviously, Microsoft's leading the way. They have OpenAI stuff in there. They're kind of the pioneers in the generative AI stuff, even though lots of other companies were playing around with it for a long period of time. And then Google's been in AI for a long period of time. They just need to convert their tools into deal with more generative type solutions, get in the whole GAN thing, generative adversarial networking. And then AWS, I think they would be pictured in the press as playing catch up, but they've kind of had those tools in there for a while. I did some courses on their AI tools. And even though it didn't point directly at generative AI, they have some catching up to do and adding those tools in the marketplace. What I saw and what they're working on, I think they'll get there pretty quickly, certainly in time for the people that are actually using this technology. You have to remember, this is a bit of a marketing show right now. So everybody's AI washing, everybody's talking about generative AI. Certainly you and I are playing that game as well because you want to be held relevant in the market. But as far as people are actually doing something and spending money on generative AI, that hasn't happened at the rate yet that everybody's predicting. So it's mostly proof of concepts and little baby systems out there. They're doing some generative AI systems, adding them on to business systems. We're not getting into the big transformative systems that everybody's predicting. And the reality is that's going to be a couple of years away. So we're going to spend a couple of years having to plan and build those things and build the components. Because if we're going to get to this thing that's truly going to be game changing, it's going to take a lot of time to build. It's going to be very expensive. We have to have a lot of detailed planning. We have to figure out how to get a hold of the training data. That's the biggest factor right now. It's one thing to have a generative AI system that is able to do some amazing stuff. But if you can't get your training data, stuff from your business systems into that system in a reliable way, then it's not going to have the capabilities you're looking for. That problem has to be solved. And most people in their databases are a mess. So they have to fix those first in some occasions to get them into the system. So I wouldn't say they're at synergy right now. I think Microsoft is certainly a little bit ahead with the OpenAI stuff. Google obviously a little behind them. And that little thing that happened this week didn't help. And then AWS is going to catch up pretty quickly. And they've had an AI solution offering for a long time. It's just a matter of, it's another pattern of using machine learning. At the end of the day, it's a matter of adding those things, which isn't hard to add. And by the way, lots of stuff out there is open source. So we just go ahead and leverage that stuff and bring it into the marketplace, localize it for what we're looking to do, put a price on it, get it into production. It's available for people out there. Suddenly we have an ecosystem.
And so now if we look at AI systems as these solutions that are, for many organizations, by default provided by the cloud provider, but as you mentioned before, also may have begun on premises and evolved into the necessity for cloud infrastructure for compute and storage support. Architecturally, a lot of people assume they're more or less like black boxes. You input the training data, data scientists do their magic with the algorithms, the hyperparameters, the modeling, and then monitor the results. But with Gen AI and the opportunity to integrate these systems more broadly within the enterprise, as components of actual applications, how would you break down, just at a high level, the technology architecture behind a typical AI system, regardless of who's providing it, what are the primary components and what are the primary considerations for any enterprise looking at making it a more central part of their ecosystem?
Yeah. Yeah. Once again, no easy questions here. I would say there's three major components that we have to worry about. Having just got through a Gen AI architecture course development thing. Number one, the data, which deals with the data sources that we're using for the training data. That's any number of structured and unstructured things inclusive of the middleware that's used to move the data from whatever place it's in now into the training models or into its training state, and the ability to perform hygiene on the data, and which is some people miss. They'll ingest poor quality data, and they'll get poor quality answers and lots of hallucinations, wonder where they came from. So that's a major part of it. And people often don't really consider how much work that is, because you're dealing with the number of systems and databases that exist within your enterprise that you're going to have to need to ingest in these systems. And those things are DB2, MySQL, a petabyte of PDF files in some instance that a client's dealing with, and lots of different forms and states. And so we need to figure out how to get that data into a state where it can be ingested into the model. And I would say that's on the data side. The fun stuff would be the model development stuff, which is everything you just mentioned. The data scientists are sitting there looking at the algorithms, how we're ingesting the data, how the patterns of data should be thought about. And that's going to be bespoke for whatever you're looking to do. And that's going to be the AI engineers and the data scientists who are sitting down and doing it. But again, we're assuming we're getting a clean data stream. We're getting clean training data from them to build these models. So it's designing the model, building the model, training the model, and getting the model into a state where it's ready to go in production. The generation of the LLM, and that's a huge part of it. And it's going to take someone who understands the generative AI tools, how the modeling tools work, and those are going to be different based on what generative AI system that you're using. One of the things I found out, there's some commonality in them, but if you look at each system, they do stuff in very different ways. And so the big architectural thing there is picking the system and tool set that you need to make it happen, and then leveraging the tool set in the most effective way to build the models that you need. And that's going to be some very smart people who understand what are the options out there, how to define what's needed in the tool set, what are the open source tools that are needed to brought in, then bringing into a bespoke configuration of a generative AI system that's going to build the models that you're able to use. So that probably the hardest part, and it's going to be very different. I guess the data stuff's going to be different too, but it depends on what your data is. And then the other one would be model management and model usage. And that's basically the administration of the prompts and the APIs that communicate with the LLM. So in other words, how you ask it a question. And of course, we're all familiar with ChatGPT, where it's saying, you write us the thank you notes, write me a song about myself and all that kind of stuff. These are mostly going to be API accessible things when they're going to be in a business stance. People are not going to sit down at a prompt and be asking lots of different questions about the data as a means of doing business. It's going to be external business systems that are communicating with the generative AI model using well-defined API sets. So that means we have to architect APIs, have API management, we have to have security, we have to have governance in play, we have to have everything in working order so people are able to use the system in a consistent way, including dealing with the special needs of security and generative AI. We can do fun things like teach it to poison the data by putting things in the prompt that we don't know is in there, and it changes the state or adds biases to the system. And that needs to be done as well. And that's going to be dependent on what you're doing with the system. But the majority of the time, I think 90% is going to be API access for business systems. I just don't see it happening another way. It doesn't really make sense. It's kind of cool to sit down in a prompt and ask, look, what are my sales going to be in 1 year if the weather turns bad, which it will do stuff like that. But normally that needs to be in line to using systems in real time. They're able to communicate with the system. The other thing you need to consider is the ethics and security around building the system. So we have to make sure that the biases are, and we're auditing for that the biases are checked, and we're doing the right things in terms of accounting how the system is going to be maintained, looking for erroneous data, looking for excess hallucinations, and actually making sure there are no biases in the system reality is there's always going to be a bias in there, but we have to have a certain leverage of a state where it's not doing something that's hurting people. For example, we had the recent court case where uh, there was a bias in the system that was picking resumes that were, downgrading people who were over 50 years old for whatever reason. But that bias got in there. People figured it out, which you can figure out externally, and they sued them, and they won. Uh, Airline in Canada recently got sued because they had a chatbot that gave them erroneous information. I wrote about that in my InfoWorld column.
Yeah,
Those things are going to happen, and the only way to get around them is to have a rigorous set of people, normally ethics related, even though you would think some of this stuff is ethics related, it is, who are checking for biases, able to test for biases, and we're constantly going into the knowledge model and checking for those sorts of things to make sure that they're removed out of the system, because that's going to get you in trouble. You got to remember, we're not dealing with a pile of code where I can look at something and I have the logic and I can see what it's doing and I can see how we're operating on it, or stored procedures and triggers and things like that. We're ingesting lots of data. We're building the models that we think that, and telling it the way it should think, and we're hoping it thinks correctly. We're not programming the system. In essence, it's reprogramming itself, each and every time, and continuously learning based on the information. Well, there's a lot of things that are cool with that. We experience those every time we use a generative AI system. A lot of things we can get wrong, and there's not enough architects. There's not enough AI engineers. There's not enough people like you and me, I think, are asking the questions and how to build those things. So my concern would be is that they're not doing the architecture, not dealing with the three things, neglecting some of the core moving parts that need to be considered, and are building systems that are subpar. So those are the three main components. There's lots of different things that go on. Obviously security, governance, API management, operations, backup BCDR. I can't remember that kind of stuff. Every time I teach a security class, like, what about BCDR? Obviously that's there. All that stuff that we do on other systems, traditional stuff, is there. We're just talking about what's net new with dealing with generative AI systems. So they're very data oriented, they're very middleware oriented, they're very engineering oriented when you deal with building the models. And then we deal with more traditional things when we're communicating with the LLMs through APIs or prompts. And so we should be good at these two sides because we've done those before. This is kind of the new part in the middle, building the models, building it for particular use.
The API aspect is interesting. In your experience, given that the system continues to learn and evolve over time, could there be a risk of API behavior changing along with the growing knowledge or intelligence of the system, whereas the results of one API call between an application and an AI system today results in something different than it may a month from now after it's gained further knowledge and insight, which may result in it trying to improve its behavior, optimize certain things. Have you run into anything like that?
Yeah, that's kind of why you use generative AI systems, is because they are going to come up with a different answer based on their additional understanding of data that's ingested into the system. We want them to behave like that. The problem is going to be inconsistency that humans see that they view as erroneous. In other words, they think that, well, I got an answer. And we do this with credit scores, right? When you look at our credit score, this month it's 600. We look at our credit score next month, it's 800. Well, that changed over time, but we're asking the same question. It's very similar with generative AI systems. So whether you're getting sales record information, sales upsigns, it's always going to be changing, and inconsistency is going to be really kind of a core component of it. Now, what you can do is build in protection so people understand why that inconsistency occurs. In other words, I see that, your credit score dropped, 200 points. It's because you had this late payment, stuff like that. And this training data was exposed as the reason to get to this. We can have the same sort of a, conversation around, somebody managing supply chains and things like that. It's always going to be dynamic and it's always going to be changing because the data is not static and the knowledge model shouldn't be static. And you're going to get different answers, by the way, from even 1 minute to the other. And that's the good thing about it. It's able to think, it's able to change its reasoning, it's able to be a flow and stuff like that. And if we're dealing with, dynamic supply chain management and we're dealing with fraud detection and all these sorts of things, it really should do it. So as engineers, we just need to know that that's going to happen and account for it in the user interface and account for it in the governance systems and all these sorts of things.
What about model explainability and the whole field of explainable AI to deal with models had to become so complex that even the engineers don't fully understand the logic within them. How big of an issue have you seen that become?
I haven't seen it as an issue yet, but I do think it's going to be an issue because you can see these things kind of taking on a life of its own, which is what we want them to do. So they become something that's matched. They become a pattern, the ability to find patterns and use patterns in different ways that we probably didn't think of. So they're in essence programming themselves to be a better AI engine, whether the human beings are carrying it or not, because we put the code in there that we want you to consistently improve yourself. So it's going to basically move to that directive. So there could be a point where we can't explain why something happened, even though it's a bit scary. But that's the reason we're leveraging complex AI systems. And I think that, if you go to a court case and, this thing, gave me an answer that got us sued, that's going to be a problem. But the engineers should have visibility and observability in the systems to have at least an inkling as to why those things have changed. So one of the tool sets I think is going to be probably extremely valuable is going to be AI and certainly AI ops observability tools that'll tell you how the model was created, what changed in the model, different logical operators, different data patterns is able to find. So we can have the explainability kind of occur as its learning is evolving.
Mm-hmm.
If we're looking at it like a black box and we're just letting it learn anything that it wants and come up with any answers that it wants, and it kind of goes out of our control, it's not going to help us because we're going to get to a point where we can't explain why it's producing these answers, and that's going to get us sued. It's going to get us in trouble. So explainability would be part of that. I don't think it's going to be a huge complex thing to get to it. I think it's a matter of using different tool sets to use it. But we probably don't have as good of an understanding of how that's going to work. I mean, I know how to operate a database. I know how to operate a middleware system. But how do you operate, something that's thinking and changing, reprogramming itself, and using different aspects of itself? And even as we start maturing with this technology, we give it, access to more things, access to more data, and it's going to come up to for its own logical conclusion. I'll give you an example of one. People were loading training data into a system that was anonymized for health records, and they were doing it to look at causality in terms of patient care, which is awesome. So no PII information was loaded in the system. They loaded it into the knowledge model, and it was able to figure out who the patients were based on looking out on the internet and filling in the data, things like that. So it unanonymized. So it was able to figure out who that data belonged to. So suddenly we have PII in the information into this particular system that's not protected as PII information. That's illegal. So those sorts of things are going to happen. We need to be aware that there's a possibility, and we need to put places in that we know what's going on at each stage of the game. We're able to explain it. Human beings are in the loop, at least from building and deploying these things.
Mm-hmm. And it's really interesting. I'm curious as this evolves how whether explainable AI tools can keep pace with how an AI system itself may want to evolve its model, whether the model at some point will outthink the capabilities of the explainable AI tools, and whether we then reach a decision, by observing it and governing it to that extent, and then reaching a point where we no longer understand where it's going. And what do we do then? We've become fully reliant upon it. Do we just pull it back, restore it to a state where explainability still exists and wait for the tools to catch up? Or do we take a risk and allow it to evolve further?
I would never let a system go off and think for itself and do something I didn't have control over, because that's going to lead to a disaster. I mean, we all saw Terminator. So I would have if I couldn't explain what the system was doing and didn't have visibility into that, I probably wouldn't let it grow. I would put a cap on the knowledge creation, at least temporarily, until I could get a indication on that.
No, I fully agree. And that's a very wise point of view to have, just in terms of approaching the whole governance of these systems, and architecturally as well, because then that unknown variable becomes, a risk factor for the entire environment. From an architectural perspective, also, you mentioned hallucinations earlier, especially in relation to Gen AI. How big of an issue has that become? What have you seen?
Well, it's obviously going to be a potential, but I don't think it's if the right data is loaded into a system and you're building the models in the right way, hallucinations are going to be fairly uncommon. So I wouldn't, and also you know what they are. You know when something is an outlier, and you can spot it and throw it out as an answer you're not going to use. And so you think about it, we have the generative AI stuff uses the adversarial network, where in essence two things are communicating one to another and checking each other out. They're verifying each other's data. That kind of model leads to very good results and very accurate results. So a lot of those things are going to be eliminated before you even see them. But we're going to have better tools for checking those things. I don't sit up at night worried about systems hallucinating and have some sort of erroneous thing that pays somebody $1 million on a $1 check or something like that. We just have too many checks in place to make it happen. But it's always something, if you're an AI engineer, you need to watch those things and learn how to manage them. But it's not this big problem that I think everybody's making it out to be.
Okay, well, that's good news. Also, in terms of data hygiene, you mentioned earlier. So again, putting an architect's hat on, the cloud environments provide capabilities to cleanse data. There's cloud automation features that integrate with AI systems that help keep our data clean, secure, protected, relevant. To what extent do you trust those capabilities? Are they very generic and vanilla and only maybe do 20% of what a given organization may need to do with its proprietary data? Or are they very thorough, and should we rely on them, or should we do more than just what they can provide?
Yeah, and this is going to have to be the last question because I got to bounce in 2 minutes. I would not rely on them. I find them wonky. Is the best way to say it. Or not, and that's because they're still developing them. So the secondary tools, the AI engines themselves are pretty well vetted. We know how they work, and they've been around for a while. They're machine learning. But the tools that sit around them that manage those things that are kind of net new around generative AI, they're at all levels of reliability and accuracy. I would be very wary of them unless we're putting them into production. We had a couple of years to break them in, and we have a tendency to rely too much on those things.
Okay, super. Thank you so much, David. We'll let you go. David Linthicum, independent technology thought leader, host of the Cloud Computing Insider YouTube channel and the corresponding best-selling book. David, thank you so much for your time today.
You got it. Thanks, Thomas.